So there is some problem in the internet connection. So I am sharing once again my slides. So all of you see the presentation screen. Okay. So as you can see here, a grammar is given to you and you need to produce a string. So as in the string, plus sign is first, and after that multiplication sign is there. So we need to first take the production in which plus sign is in the left hand side. So out of these three productions, we need to first take the production in which plus sign is in the left hand side. So we first take the first production here. So this is the first production. As you can see, here leftmost is written, LM is written. So after that we need to change the first E from the left hand side, uh, uh, then convert it into E produces ID, because E produces ID is also there in the third production. So we can convert the first E or replace the first E with ID. So here you can see the ID is there. So now we have ID plus E. So in at this step we already produce id plus from the string. So after that, from E, from E we need to also insert into there. So we can take the second production and replace this E with E into E. So here you can see that the previous E is replaced by E into E, and after that we need to convert this E into ID by using this production. E produces ID, and finally we convert this E into ID by using the production E produces ID. So at last we can get the required string. So this can be also shown by using the parse tree. As you can see here, here top down approach is we are adopting the top down approach. So first this E is here, this E is here, and then in the second step we can have E plus E in the second step, and after that in the third step you can also number this in here. So here this is the step, and after that we 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 convert this e into id, and now this e can be converted to e into e, and after that this e is being replaced by id, and finally this e is being replaced by id. So finally we get id plus id into id. So here we adopted the top down approach. Top down, that's why it is termed as top down parsing. All of you understand it? Just write in the chat box so that we can move further. Okay. So basically, the classification of top down parsing. So top down parsing is also classified into various types. So first is with backtracking. In with backtracking, brute force technique is adopted, and the second technique is without backtracking. And here the techniques adopted are recursive descent parsing and predictive parsing, and there are various names for this: predictive parsing or non-recursive parsing or ll1 parsing or table driven parsing. All can be termed as the same. So this can be shown with the diagram: a top down parser, then the recursive descent parser, and the recursive descent parser has been converted into backtracking and the non-backtracking. So there are two forms: backtracking form and the non-backtracking form. So the non-Batrican form is also called as predictive parser, and from predictive parser we can generate the LL parser. And our main aim is to generate the LL parser basically. And here you can see the Batrican form is also called as the brute force technique. So Batrican form is brute force technique, and the non-Batrican form is called the predictive parser, and from the predictive parser we generate the LL parser. So this is the classification of top-down parsing. So let us discuss each of these parsers one by one in the next slides. So this is the flow chart of top-down parser. So as you can see from the flow chart, first a top-down parser is there. Then we need to first remove the left recursion and left factored grammar. So to make it suitable for the top-down parsing. So as we already discussed with example, the removal of left recursion and left factoring. After that, it is in the form of recursive descent parsing, and once we remove the backtracking, then it is converted into predictive parsing, and the predictive parsing use tables, remove recursion, and after that the non-recursive predictive parsing we can get. So basically in recursive descent parsing, the parser may have more than one production to choose from for a single instance of input. Whereas in predictive parsing, each step has at most one production to choose. Just as you already know in the NFA and DFA, in the DFA it is deterministic. So only one production or one state is uh, you can have one state from the other state. There is no choice, but in the NFA or non-deterministic finite automata there is choice with every transaction. So just in the case of recursive descent parsing and predictive parsing, so there might be instances where there is no production matching the input string, making the parsing procedure to fail. So this parsing is not always. You cannot generate the string with the parser always. Sometimes the parsing procedure also fails. So by taking the example, we can check in which cases or in which example the parsing procedure is fail, and in which cases we can generate the string from the parser. So all of you understand it? Just write in the chat box so that we can proceed further. Okay. So first is recursive descent parsing. So recursive descent is a top-down parsing technique that constructs the parse tree from the top, and the input is read from left to right. So in all the top-down parsers, the input is read from left to right. So it uses procedures for every terminal and non-terminal entity. This parsing technique recursively parses the input to make a parse tree, which may or may not require backtracking. As we see in the diagram, after recursive descent, the parser may be in the backtracking mode, or it can be in the non-backtracking mode. But the grammar associated with it, if not left factored, cannot avoid backtracking. So if a grammar is not in the left factored, then it is in the backtracking form of grammar. A form of recursive descent parsing that does not require any backtracking is known as the predictive parsing. So basically, in top-down parser, the important topic is predictive parsing and the LL grammars. So here a note is given. This parsing technique is regarded recursive. So why it is called as the recursive descent parsing? So this parsing technique is regarded recursive as it uses context-free grammar, which is recursive in nature. Basically, we already discussed the context-free grammar in the theory of computation. So context-free grammar is recursive in nature. That's why this parsing technique, which can be generated from the context-free grammar, is called as the recursive. Right. So these are some of the important points related to the recursive descent parsing. So moving to the next slide. So let us discuss each one by one. So first is backtracking. So all of you know the backtracking method or not? As this topic is already covered in your data structure and algorithm subject. All of you know the backtracking method or not? If anyone does know, and anyone knows it, or all of you does not know it. So let us discuss this method by using the example. So first you can see a top-down parser starts from the root node, which is the start symbol, and matches the input string against the production rules to replace them if matched. As we already discussed with the example before, to understand this, take the following example of CFG. So basically, you have given the CFG grammar, and here you can see 5 productions are given by using 3 non-terminals. So basically the start symbol is S. So it will start with S from the production rules and will match its yield to the leftmost letter of the input. So here you can see from the start symbol, you can go either to this production or either to this production. And in both production, you can see small r is at the leftmost side. So the very production of S produces RHD. So we can take the RHD production matches with it. So the top down parser advances to the next input letter, which is E. So here we need to find a letter E is there. So basically, this example is not complete, but you can basically take it from actually, as it is not complete, so you can take, we need to find it E or generate E from this. So here you can see from the X production, out of OA and EA, we need to take EA because we need to generate E from it. So moving to the next slide, you can understand it much more better in the next slide. So, so here you can see from the diagram. So only 5 minutes are left for this meeting. So as you can see from the diagram, so here S is converted to R, H and D. And now S is now H is there are 2 productions which are starting from H. One is OA and the other is EA. So once if you can see from this sentence, the parser tries to expand non-terminal H and checks its production from the left. H produces OA. So first we try the first option. H produces, so basically there are 2 production. H produces OA and H produces EA. So first we try the first option. H produces OA, but it does not match with the next input symbol. So we need to backtrack it. So here backtracking is allowed. So backtrack you can see from the this diagram, from O we can backtrack with X, because X generate the OA, so we can backtrack or go back to the X symbol. Then after that we can go back to the X symbol and we can try with the second production, which is X produces EA. So here you can see we replace the OA production with the EA production. So this is the next production we can generate it from X. So this can be possible by using the backtracking method. So by using this method, backtracking method, we can generate the E, a symbol E, which we need to find. So now the parser matches all the input letters in an ordered manner. So the string is accepted. So that's how the string is accepted by using this backtracking method. So backtracking method is applicable whenever we need to find, or we cannot know where to move to the next where to move to the next input. So here you can see, first we try with the X produces OA, and as we can see that it is not matching with our string, or what we desired in our output, so we can backtrack it by using the backtracking method, and after that we generate the string. So this is the use, or this is the purpose of backtracking method. So moving to the next slide. So brute force technique is based on the backtracking method. So these are some of the points related to the brute force technique. So whenever a non-terminal, whatever we discussed in the example is being written in these lines. So whenever a non-terminal is spent first time, then go with the first alternative and compare with the given input string, as we done with the first input string OA, but it does not match. If matching does not occur, then go to the second alternative and compare with the given input string. So as in our example, OA does not match, so we can move to the second alternative, which is EA. If matching again not found, then go with the alternative, and so on. In the case where there are more alternatives, then we can move to the next alternative. Moreover, if matching occurs for at least one alternative, then the input string is passed successfully. So whenever we get a string which is matched, then our our string is matched, and the parsing is successful. So all of you understand it? Just write in the chat box. Okay, so that's all for today's class, and the next topic we will discuss in the next class. Okay, thank you very much. Now you can leave this meeting.